Let's continue with our next section, 5.2, ellipses. Our objectives are to 1, verifying the standard form of the equation of an ellipse, 2, graphing ellipses, and 3, finding the equation of ellipses. Ellipse equations. The definition of an ellipse is the set of all points on a plane and the sum in which the distance from the two fixed points called the foci is a constant. So let's continue reading. We will be studying ellipses elongated either horizontally or vertically. So considering the two fixed points mentioned in the definition, we can picture a loose piece of string tied on two tacks. They are placed either side by side or up and down from each other. And the two tacks represent the two foci. If we put a pencil inside the string and keep the string tight as we circumvent the two foci, we will draw an ellipse. Because the length of the string does not change, the sum distance of the two tacks will remain the same definition as an ellipse is satisfied. So we're saying is, let's say these are two tacks, and we have a string. Well, if we put our pencil, that's supposed to be a pencil, we put our pencil at the end of the string and just pull the string tight and keep going around, this figure it makes is an ellipse. So it's like a flattened circle. Now, depending where you have your foci, will create a special type of ellipse. So this will be more of a vertical ellipse because it has longer sides up and down. Or we can have one that's a bit more flatter horizontally. So we have our two tacks there, pull our string tight, draw our pencil. And if we pull our pencil with the string as far as we can, keeping it tight, we'll create this figure. This special figure is called an ellipse. And what makes it so important is that the figure, the amount, the distance of the string is the same around, meaning the distance from your foci to your endpoints. All right, the list of components involved with an ellipse will include the following. The foci, so two focus points. And plural of focus is foci. Two fixed points placed side by side or up and down from each other. We have the center, the midpoint of the line connecting the two foci, also the midpoint of the vertices and endpoints of the minor axis. We have a major axis, which is going to create the longer side. The longer of the two axes, the minor axis, the shorter of the two axes. Your vertices, the endpoints of the major axis, and your endpoints of your minor axis. So from our textbook, we have our equation of ellipse, and there it is. Just like a circle, we have a center made up of h and of k. And just like a center, remember to change the signs from your formula. When you're trying to get your center from your formula, change the signs. A is the distance left and right from the center to either the vertices. B is the distance up and down the center from the vertices or co-vertices. And C is the distance along the major axis to the foci. So this is the formula. C equals a squared minus b squared, and C equals b squared minus a squared. How do you know which formula to use? Your formula is actually c squared equals longer side minus the shorter side. So you don't have to really remember the letters, but you do have to know that it's longer minus shorter. And actually, if I'm not mistaken, A and B change. It's not always right and left because these formulas change. But the way you do know which one moves left and right is because, do you see how we have an X here? And we think of a line or a plane. We have our X-axis that goes this way. left and right. So the number that goes under the x goes left and right. And then we have our y-axis that goes up and down. So the number underneath the y is the one that goes up and down. And we'll see that in examples. So let's do example 1. Graph the following ellipse by finding the center, co-vertices, and foci. All right, so do we have a plus or minus within our squares? We don't, right? So we know that our center is at 0, 0. Okay, now we have to look at these numbers. Now from our formula, we see that, you notice how they're being squared? So if we want to pick out those numbers, I have to take the square root. So here we have 16. So I take the square root of 16, which gives me 4. All right, because it's under the x, I know I have to move it left and right. So I'm going to move from the center 4 points left and right. Now taking a look at this other number, 25. We see that the 25 is under the y. And I know I want the square root of that, so I want 5. So this tells me from the center, I'm going to move 5 units up and down. All right, that's how I like to think of it. Now let's read how your text says it. For this ellipse with the center at the origin, the 4 intercepts will be the vertices and the endpoints of the minor axis. Finding the x-intercepts, we have the following. So for our x-intercepts, letting y equal 0, we get that we have a x plus or minus 4. For our y-intercepts, letting x be 0, we get a y-intercept of 5. Now solving, c squared equals b squared minus a squared. So remember, it's always largest minus smallest. So we have 25 as our bigger number minus our smaller number, we get 9. So we get c squared equals 9, and we want c. So we take the square root, we get c equals 3. And that's the distance up and down from the center to the foci, since the major axis is vertical. All right. So let me help you figure out our pieces. All we really need are our center, which we found. And then from our center, we use these pieces. We're going to go from the center 4 units up and down, and from the center 5 units up or down. So we have our center at 0, 0, and we're going to go 5 up, 1, 2, 3, 4, 5, and 5 down, 1, 2, 3, 4, 5. And then we said 4 left and right. 1, 2, 3, 4, 1, 2, 3, 4. Always label your points. So we have 4, 0, negative 4, 0, 0, 5, and 0, negative 5. Now your foci, your focus points, that was the c squared equals 25 minus 16. We got 3. That's this point here. Now we need to label that because that's the special 2 points. Those are your thumbtacks, so that we tie the string from there according to our introduction, how it's explained. And it's an important point to label. Now, if you want to, that's something I always see best to fill in last, because then we can see which side is longer. All right, we see that our graph is longer vertically. So that means our focus points are along our longer side. Although the 4 intercepts here were the vertices and the endpoints of the major axis, this process will be limited to ellipses with a center at the origin. Therefore, instead of finding intercepts, we will use the following approach. First, you want to find your center. Determine the values of A and B, distance from the center to the vertices, and co-vertices. The larger of A or B will determine the major axis. If A and B are equal, we have a circle. And then we use our equation to find our focus points. The distance on the major axis to the foci. An easy way to determine which equation to use is to understand that in order for the equation to have a real number solution C, you must have the expression that is a positive value. So that's why it's always larger minus the smaller. Okay, so for example we got that A squared was 16, which gives us A is 4. The distance from the center to the endpoints of the major axis is the same direction as the x-axis, which can be remembered by noticing that A squared is under the x term, just like we said earlier. And we see that B squared is 25, which tells us that B is 5. The distance from the center to the vertices in the same direction as the y-axis, which can be remembered by noticing that B is under the y term. And our focus points, our foci, can be found by using that equation. Remember, larger minus smaller. So let's take this new equation. Can we easily pick out our center? Yeah, right. Our center is now at the origin. We have an h of -2 and a k of 1. So our center is -2, comma, +1. Remember the sign change. Okay, and then we have our numbers. Let me use different colors. So we see for this first one, it's under the x. Because it's under the x, it goes left and right. I have 9. That looks like an A. We have 9. I take the square root of 9, which gives me 3. So I know I'm going to go 3 units left and right from the center. And then under the y, which goes up and down, our y-axis goes up and down, I have a 4. I take the square root of it and get a 2. So I know I'm going to go 2 units up and down from the center. All right, so we already have our ellipse. We have our center and we have our points. We see that we're going to go along the x-axis. It's the longer side. So it's going to look something like this. Maybe not so drastic. Since the equation is written in standard form, we can determine the following. Our center is -2, 1. My A is 3. So the distance to the left and right will give us the points -5, 1, and 1, 1. We have a B of 4, which gives us a B squared of 4, which gives a B of 2. So we have other axes, points of -2, 1, and -2, 3. How did they get those points? Well, they're just working from the center. So here, since moving left and right, we're going to take -2, 1, and we're going to take our 3, and we're going to add a 3, and then we're going to subtract a 3. So 2 plus 3 gives us 1. So I have 1, 1. And -2 minus -3 gives us -5, 1. Now for our next one, we see that we have a B of 2. So we're going to add 2 to the y because it goes up and down. And our y-axis goes up and down. So I have -2, 1, and I'm going to add 2 and subtract 2 from the y. So I have 1 minus 2, I get -1, and I have 1 plus 2, I get 3. So I have these points, -1, comma, -2, comma, -1, and -2, comma, -3. All right, let me erase all those circles I wrote in between. I think at some point it just isn't really helpful. All right, last piece, we have to find our focus points. So for that, we're going to go ahead and have c squared equals the longer side minus the smaller side. So we had 9 minus 4. 9 minus 4, we get 5. C squared equals 5. We take the square root. and you get C is about, you can punch out into your calculator and get a decimal point. I think it's about 2.2, 2.1, I'm not too sure. All right, so here we have our points. We have our center, and we moved points up and down and left and right. We said we're going to move left and right 3 units. So we go 1, 2, 3, 1, 2, 3, and then we say we're going to go up and down 2 units. So I have 1, 2, 1, 2. And then you can go ahead and kind of estimate where your focus points would be with that square root of 5. All right, C. So we have a problem here. It doesn't look like our standard ellipse. It doesn't look like x minus h squared over something squared plus y minus k squared over something squared equals 1. We don't have it in standard form. So, as with circles, the standard equation of an ellipse contains only one copy for each variable. So we must again complete the square. All right, so we start off by grouping our x's and grouping our y's. And remember, any number that doesn't have a x or a y, move it to the other side of your equal sign. Okay, so for this one, we have to make sure that our x is by itself. So for this case, this x is not by itself, right? I have to get rid of that 2. So let's factor a 2. If I factor a 2, I'm left with 2 divided by 2 is just 1, so I have x squared. And if I divide negative 8 by 2, I'm left with negative 4x. And same thing for our y's. I can factor out a 3, and I'm left with a y squared plus 2y. So that we're here. Notice we kept the space open because we have to add our something that we find. All right, now let's complete the square. Let's recall that our formula to find that extra value is b divided by 2 squared. All right, so my b is negative 4. I have negative 4 divided by 2, which is negative 2. And I'm going to square that to get 4. So I'm going to go ahead and add 4. And I would want to add 4 here too, but because I have this 2 on the outside, I have to multiply it first. So 4 times 2 gives me 8. I'll write an 8. Now let's do the same thing for our y's. So for our y's, remember it's b over 2 squared. My b is positive 2, so I have 2 divided by 2 squared. 2 divided by 2 is 1. So I'm going to go ahead and square that to get 1 again. So I'm going to add 1 to both sides. So I have plus 1, and then I need to multiply on the outside. 1 times 3 plus 3. Now, the way to remember this might make more sense if you're still living in your parents' home and I don't know. So the way I remember this is think of these parentheses as your parents' home, and you need to ask permission to go out. So you have to ask your mom if you can go out or your dad. So that's how I was once told when I was younger, and that always helps to remember. All right, we must recognize that each set of parentheses has a leading factor. That's the ask your parent part. Ask them if you can go out. Therefore, we add the 4 and 1 to the parentheses with the leading factors of 2 and 3. All right, so these are these points right here. We asked for permission, but we haven't written up above. All right, we go ahead and we add all these numbers up, we multiply them and add, and here we factor. Remember, it's always a number before you square. So I went ahead and I highlighted those numbers. So we have a 2 and a 1. That's always a number before you square. So we have x minus 2 and y plus 1 squared. Meaning this factors to be x minus 2 times x minus 2 repeats. So we square it. This factors to be y plus 1 times y plus 1, which is twice, so we square it. And we leave those leading coefficients in the beginning. Okay, one big thing is at the end, my equation needs to equal 1. And it's not a 1, it's a 12. So what can I do to fix this? Well, I can divide by 12 on both sides of my equal sign. So if I divide by 12, I'm left with this position here. All right, I know 12 or 12, that gives me 1. But what about these numbers here? Well, these numbers, they simplify. So simplify your fractions. They also divide into each other. We think of it reverse. 12 divided by 2 is 6, and 12 divided by 3 is 4. So that's the number you get on the bottom. Okay, so so now that we have it equal to 1, first piece is to figure out your center. All right, so therefore the ellipse has a center of 2, comma negative 1. I have an a squared of 6, which gives me square root of 8. So I'm going to add and subtract. Did I say 8? Square root of 6. We're going to add and subtract the square root of 6 to the left and right because our x-axis goes left and right. And then my y-axis has a 4. I have a b squared of 4, so I have b of 2. So I have a distance up and down from the center. So I add and subtract 2 to our y's. So if figuring all these points is giving you a bit of a headache, you don't have to do everything mathematically and adding and figure out your points straight off the bat. You can start off with your center and then count off. You said we're going to go 2 up and down. All right, 1, 2. All right, I have my point. What is that point? You can take a moment to look carefully at your grid and see you have 2, comma 1. And you go 2 down, plot your point. Then you can start to think, what point is that? 2, comma negative 3. Lengthwise, that was a radical. I can punch into my calculator, maybe to 1 decimal point, and count left and right. Right. Now don't forget your focus point. So it's always your bigger number minus your larger. So we have that here. C squared is equal to 6 minus 4, which is 2. So our C is square root of 2. So try your best to plot your points. So C would be that green number, this point here. Those are your focus points. And we have our graph. Find the equation of an ellipse. The final topic regarding ellipses will be the reserved question as compared to each of the questions above. The question will start with given information, and the question will ask us to find the equation of an ellipse. So example 2. Find the equation of a standard ellipse with vertices at 0, plus or minus 5, and a foci at 0, plus or minus 3. All right, so I have to remember what these are. Our vertices, those are your endpoints, right? So those are points that can be found on our endpoints of our ellipse. Our foci, those are your tick marks or tacks, right? So those are not endpoints, but they go along the major axis. So meaning if our ellipse is like this would be our major axis. If our ellipse opens vertically or is more vertical, our ellipse will be the longer side. So this tells me that, hey, whatever graph I have, it's going to tell me which side is going to be longer. All right, so let's keep in mind what we need. We need the center, we need our axis points. And we already know our foci, so that'll be helpful. So let's kind of just draw a sketch of what we have. We're given that we have a plus 5 and a minus 5 from the center, and we have a 3 to the left and right. I'm sorry, up and down. Well, we see that the center of these focus points is 0, 0, which will also give us the center of our equation. Now, recognizing the midpoint of the two vertices of the two foci gives us a center at 0, 0, our equation of an ellipse can be written so far as this. Now we're just left to find A and B. But we see that our y, because we have these focus points, we know our graph has a major axis along this way. So we know that the number under the y, which goes up and down, is going to be 1, 2, 3, 4, 5 units. So if I have 5, and if I square it, I get 25. So I know that the number under the y is going to be a 25. Great. So we have that here. The distance from the center to the vertices at 0 plus or minus 5 is 5 units up and down. So it's telling us that b is 5. So then b squared is 25. The final component is left to determine the a. Can you think of what we can use to find it? The distance from the center to the endpoints of the minor axis. Our sketch above cannot be used to determine the value, but we just determined that b is 5. And the distance from the center, 0, 0, to the foci is plus or minus 3. So c is 3. So since b squared determines the major axis, we have that c squared equals b squared minus a squared. So we know c squared is 3 squared, and we know b squared is 5 squared. Now we're just left to find a squared. So we have this here, right? So we subtract 25 to both sides, and we're left with 16, negative 16, right here. So we have negative 6 equals negative a squared. We divide by a negative 1, and we're left with a squared equals 16. So we have our leftover piece. We can solve this equation as a equals 4, but since the equation has a final component of a squared, we have the equation of the ellipse as follows. So this is our answer. Example 3. Find the equation in standard form of the ellipse with a minor axis of length 4 and the following vertices. All right, so it's telling us a minor axis, so it's going to be the shorter side of length 4, and your endpoints, your vertices at negative 7, 1, and 1, 1. Using the vertices and the minor axis of the length 4, you can sketch what we have so far. So here we have our vertices. And we have the length of our minor axis. So we can figure out some stuff, right? We see that if our minor axis, the whole thing is 4, then half of it, because we're going to have a center in between, we're going to have 2 units and 2 units, right? And it goes up and down, right? And our y-axis goes up and down. So I know that the number under the y is going to be a 2 squared. It's going to be 4. I have some pieces, great. Now I need to figure out the center piece. Is there a way to find a center piece giving 2 points? is there some way where I can possibly find that middle point? We can, right? We've seen it before. Now we recognize the midpoint of the two vertices that gives us the center. So we use the midpoint formula. This is your midpoint formula. You label your points, we add the x's, divide by 2, add the y's, divide by 2. So my x's are -7 and 1, and we divide them by 2. My y's are 1 and 1, we add them and divide by 2 to get -3, 1. This is our center. All right, using the center in our equation of the ellipse, it can be written as this. So we have our h and our k. That's all we have so far. But we have a bit more. We know that the number under the y should be a 4. The distance from the center to the vertices is 4 units left and right. So giving a equals 4, giving the equation as this. So it says is from the center, which was the point -3, 1. From -3, 1, we can see that we can move 1, 2, 3, 4. That's 4 units, right? 1, 2, 3, 4 along my x-axis. So I know that the number under the letter x is going to be a 4 squared, which is 16. And we already found our 4. The length of 4 of the minor axis will also determine the distance from the center to either endpoint of the minor axis, 2 units. So b equals 2. All right, that's the entirety of our section. If I can remind you of your formula and point out some key pieces. So we have the formula of our ellipse. Remember that your x tells you a lot. If you're ever in a bind, remember you can always draw yourself a little dummy Cartesian plane and think, which way does my x-axis go, which way does my y-axis go? That will give you a hint as to how these numbers work, left, right, up, or down. And also remember that it has to be set equal to 1. If it's not, we need to divide by whatever number that may be. All right, that's it for this section. If you have any questions, feel free to post them in our discussion board or email me. Thank you.